Architects of the Ancient World, a history of biblical engineering. The Bible recounts the rise and fall of civilizations, but woven into its spiritual narrative is a chronicle of some of the most ambitious engineering projects in human history. These were structures erected without the benefit of tungsten steel, reinforced concrete, or hydraulic crane. Yet, they challenged the limits of physics and logistics in ways that still baffle modern engineers. Some were built to survive global catastrophes, others were designed to pierce the heavens, some were mobile sanctuaries for a wandering nation, others were fortresses meant to stand for eternity. In this analysis, we strip away the purely symbolic interpretations to look at grit, the mortar, the wood, and the stone. We will examine these constructions as real projects with physical consequences, understanding that only by knowing how they were built can we truly understand why they mattered. The first naval engineer, the physics of survival. The history of biblical construction begins not with a temple or a tower, but with a vessel in the antediluvian world described in Genesis. A man named Noah received a commission that defied the logic of his time. He was not asked to build a boat for trade or exploration. He was tasked with building a life support system for a biological bottleneck, the design philosophy, stability over speed. The construction of the ark was the first major project in biblical history, and it began with a fundamental engineering choice: the rejection of hydrodynamics related to speed. Traditional shipbuilders prioritized the bow and stern designs to cut through water and sails or oars for propulsion. The ark had none of these. Its dimensions, 300 cubits long, 50 wide, and 30 high, created a ratio of 6:1. Modern naval architects recognized this ratio as optimal for stability in turbulent waters. The ark was essentially a massive, rectangular barge. Its purpose was not to go anywhere. Its purpose was to simply be. To float upright while the world drowned. The design prioritized internal volume for cargo and immense buoyancy to support the combined weight of thousands of animals and food supplies. Material science, gopher wood and bitumen. The logistics began with the forest. The text specifies gopher wood, often interpreted as cypress or a similar resinous conifer. This choice was critical. Noah needed a timber that was abundant, straight-grained for planking, and naturally resistant to rot. But wood alone is porous. The most crucial phase of this construction was the ceiling. Genesis records the instruction to coat the ark inside and out with pitch. This was the first industrial application of waterproofing. Noah likely used natural bitumen or tree resin, boiled down to a viscous tar. Applying this was grueling, toxic work. It wasn't just painting, it was impregnating the wood to ensure that under the immense hydrostatic pressure of the floodwaters, the hull remained watertight. Structural integrity. The ark was organized into 3 levels with internal compartments. Structurally, these compartments acted as a honeycomb lattice. In modern shipbuilding, this is known as a bulkhead system. These internal walls prevented the hull from twisting, torsion, or snapping, hogging and sagging under the stress of giant waves. If the ark had been a hollow shell, it would have collapsed. The internal cages and rooms provided the necessary rigidity to keep the vessel intact. This was not a project of improvisation. It required decades of repetitive, standardized labor. A single structural error, a weak beam, a missed seam in the pitch would have resulted in total, catastrophic failure. The ark stands as a testament to functional design, a machine built for a singular, terrifying purpose. 2. The vertical city. The innovation of Babel. After the flood, the narrative shifts to the plain of Shinar. Here, humanity embarked on its first collective megaproject, the Tower of Babel, while often remembered for its theological implications, Babel represents a massive leap in construction technology. The revolution of the brick. The biblical text highlights a specific technical detail. Come, let us make bricks and bake them thoroughly. They used brick instead of stone and bitumen for mortar. This is the moment humanity moved from finding materials to manufacturing them. In the alluvial plains of Mesopotamia, stone was scarce. There were no quarries nearby. Instead, the builders turned to the abundant clay of the river valley. The innovation wasn't just using clay, it was baking it. Sun-dried bricks are weak and dissolve in rain. Kiln-fired bricks, however, undergo a chemical change called vitrification, becoming as hard and durable as rock. This allowed for the standardization of building materials. Every brick was the same size and weight, which meant walls could be built straighter and higher than ever before. The ziggurat form and bitumen mortar to bond these bricks. They used bitumen asphalt, which bubbled up from natural deposits in the region. Bitumen is a superior mortar for waterproofing and has a slight elasticity, allowing the structure to absorb settling or minor tremors. Without cracking, the tower was likely a ziggurat, a stepped pyramid. This design is structurally sound for height because it distributes weight over a wide base, growing narrow as it rises. The objective was verticality, to build a landmark visible from miles away, serving as a gravitational center for civilization. The failure of logistics. Babel was a project of centralization. The text states their motivation: so that we may not be scattered over the face of the whole earth. It was a rebellion against expansion, an attempt to consolidate power in one urban center. However, Babel proves that engineering is useless without management. Construction of this scale requires a common language, not just linguistically, but operationally. It needs a unified chain of command and standardized instructions. When communication was disrupted, the confusion of languages, the logistics collapsed, the workforce could no longer coordinate. The project was abandoned not because the bricks failed, but because the organization did. It remains a monument to the necessity of unified communication in complex engineering. 2. The architecture of pilgrimage. The Tabernacle. Centuries later, the focus shifts to the Sinai Desert. The Israelites fleeing Egypt needed a center of worship, but they were nomads. They could not build a stone temple. They needed a structure that was majestic yet mobile. The result was the Tabernacle, a masterpiece of modular engineering, a prefabricated cathedral. The Tabernacle was likely the first recorded instance of a fully prefabricated building. It was designed to be assembled, disassembled, transported, and reassembled hundreds of times over 40 years. The structural core consisted of vertical boards of acacia wood. Acacia is dense, heavy, and resistant to desert pests. These boards were overlaid with gold, but you cannot simply stick wooden boards into the sand and expect them to hold up. Heavy roof coverings. The solution was a system of sockets. The foundation system. The text describes silver basis sockets, cast from the melted contributions of the people. Each wooden board had tenons, protrusions that fit precisely into these heavy silver bases. The silver provided to things a stable, level foundation on uneven ground, and a low center of gravity to anchor the walls against high winds. To lock the walls together, the engineers used a system of gold rings and horizontal bars. These bars slid through the rings, turning individual boards into a single, rigid wall. It was a click-and-lock system, centuries ahead of its time. Thermal and protective engineering. The roof was not a single tarp, but a complex, four-layered system, fine linen. The innermost layer, visible only from inside, depicting cherubim, goat hair, a coarse fabric that naturally repels water and swells when wet too. Seal gaps, ram skins dyed red, a durable leather. Layer, badger or sea cow skins, the outermost layer, tough and resistant to the abrasive desert sand and sun. This layering provided thermal insulation for the priests working inside and protected the gold and fabrics from the harsh environment. The logistics of holiness internally, the space was strictly zoned, the holy place housed the menorah, a solid gold lampstand, the table of showbread, and the altar of incense. The layout was not random. It optimized circulation in a confined space while maintaining the sanctity of the ritual objects, separated by a heavy veil. Was the Holy of Holies, a perfect cube housing the Ark of the Covenant. The architecture dictated the hierarchy. The closer one got to the center, the more restricted the access. When the glory cloud descended, the tabernacle became the operational hub of the camp. Its assembly and disassembly were not chaotic. They were a military drill. Each Levite clan had a specific responsibility: one group for the curtains, one for the boards, one for the furniture. This logistical precision allowed a nation of millions to mobilize efficiently. For the failed fortress, the walls of Jericho. As the Israelites entered Canaan, they encountered a different kind of engineering, military fortification. Jericho was the gateway to the land, and it was built to stop armies. The anatomy of a fortress. Jericho wasn't just a city with a fence. It was a sophisticated defensive complex. Archaeology and biblical descriptions sug. A double-walled system. The revetment at the base was a stone retaining walls, several meters high. The glacis, above the retaining wall, was a steep slope glacis of plastered or slippery surface, making it nearly impossible for soldiers to climb. The upper wall, at the top of the slope, stood the main wall, constructed of mud bricks. This tiered defense pushed attackers away from the city center, exposing them to arrows and stones from above. By ancient standards, Jericho was impregnable. It was a machine designed to resist battering rams and sieges. The structural collapse. The biblical account of Jericho's fall is unique because it describes a sudden, catastrophic structural failure unrelated to siege warfare. There were no catapults, no sappers digging tunnels, and starvation. The text says the walls fell down flat, literally, fell beneath themselves. From a forensic engineering standpoint, this describes a failure of the foundation. If the retaining wall at the base gives way, the earthen rampart and the upper brick wall slide downward and outward, creating a ramp of debris. While the region is seismically active, the Jordan Rift Valley, the narrative connects this collapse specifically to the completion of the divine command, the marching and the shouting. The impregnable engineering of Jericho failed not because the design was flawed, but because the force applied against it was supernatural. The debris from the walls formed the very ramp the Israelites used to storm the city. The permanent house, Solomon's temple. With the conquest complete and the kingdom established, the mobile tabernacle became obsolete. King David dreamed of a permanent house, but it was his son, Solomon, who realized the vision. The temple Solomon represented the transition from temporary to eternal, from wood and tent pegs to stone and gold. Logistics of an empire. Building the temple was a logistical operation of international scale. Israel did not have the large timber required, so Solomon negotiated a trade deal with Hiram of Tyre. Massive cedars were cut in the mountains of Lebanon, floated down the Mediterranean coast in rafts to Joppa, and then hauled overland to Jerusalem. The stone quarrying was equally impressive. The Bible records a fascinating detail. No hammer, chisel, or any iron tool was heard at the temple site while it was being built. This means the entire building was prefabricated. Every massive limestone block was measured, cut, and dressed at the quarry. They were transported to the site and fitted together like a giant 3D puzzle. This required a level of project management and standardization that rivals modern construction. The weight of glory. The interior of Solomon's temple was a structural challenge. The stone walls were lined with cedar boards, and these boards were completely overlaid with gold. Gold is heavy, 19.3 grams per cubic centimeter, covering the entire interior surface, walls, floor, ceiling added immense dead load to the structure. The foundation had to be incredibly robust to support not just the stone shell, but the weight of glory inside in the Holy of Holies. To massive cherubim made of olive wood and overlaid with gold-touched wing to wing, spanning the entire width of the room. This was a mixed media construction integrating stone, timber, and metal into a cohesive whole. It stood for centuries as the jewel of the Middle East, a physical manifestation of stability and wealth, until it was destroyed by the Babylonians, who stripped the gold and burned the structure, proving that even the most magnificent engineering cannot survive political conquest. The Imperial Complex, Herod's Temple. The final chapter in biblical construction is the Second Temple, specifically the renovation by Herod the Great. Herod was a tyrant, but he was also one of the greatest builders of the ancient world. His vision for the temple was not just religious, it was imperial. The artificial mountain. Herod's problem was topography. Mount Moriah was a ridge, not a flat plain, and it was too small to hold the massive complex Herod envisioned. His solution was brute force engineering. He built a box around the mountain. He constructed for massive retaining walls and filled the space in between with earth and rubble, creating a vast artificial platform, the Temple Mount. This platform remains the largest man-made structure from antiquity. The master of stone to build the retaining walls. Herod used limestone blocks of incomprehensible size. The western stone, located in the tunnel along the western wall, is estimated to weigh over 500 tons. It is one of the heaviest objects ever moved by humans without powered machinery. The masons used a technique called dry ashlar masonry. The stones were cut so precisely that no mortar was needed. They were held together by gravity and friction. The edges were chiseled with a distinctive margin draft that is the signature of Herodian architecture. The hydraulic system, a complex this size, hosting hundreds of thousands of pilgrims during festivals, needed water. The temple was an industrial machine for sacrifice. It required water to wash away the blood of thousands of animals and to purify the worshippers. Herod's engineers built a vast network of aqueducts and cisterns. The cisterns beneath the Temple Mount could hold millions of liters of rainwater. The drainage system was equally sophisticated, channeling waste and blood out of the holy precincts and into the Kidron Valley. The empty chamber. Architecturally, the sanctuary followed the layout of Solomon's temple, the holy place and the Holy of Holies, but there was a haunting difference. By Herod's time, the Ark of the Covenant was lost. The Holy of Holies, the architectural climax of the entire complex, was an empty room. It had the dimensions, the thick veil, the gold, and the marble, but the central object of its function was gone. It was a shell of sanctity. The final dismantling. Herod's temple did not fall due to structural failure or age. It was murdered in 70 AD. Roman legions under Titus breached Jerusalem. The temple was the center of resistance. When the Romans set fire to the sanctuary, the intense heat caused the gold overlay on the walls and roof to melt. The liquid gold seeped into the cracks between the massive stones. After the fire died down, Roman soldiers, driven by greed, pried the stones apart one by one to scrape out the gold. This fulfilled the prophecy that not one stone will be left on another. The destruction was total. The building wasn't just knocked over. It was disassembled. Today, only the retaining walls of Herod's platform remain, including the western wall, standing as a silent witness to the scale of what once stood. Odd their conclusion, the legacy of biblical construction. When we analyze these 6 constructions, the Ark, the Tower, the Tabernacle, Jericho, and the 2 temples, we see a progression of human capability and divine interaction. Noah's Ark taught us that engineering can be an act of obedience, prioritizing survival over aesthetics. Babel demonstrated that technical ability is meaningless without social cohesion. The Tabernacle introduced the concept of modular, mobile architecture, proving that sanctity is not tied to a location, but to a presence. Jericho's howled that no static defense is invincible. Solomon's temple displayed the height of resource integration, bringing the best materials of the world to one place. Herod's temple revealed the power of scale and the tragedy of a hollow monument. These were not myths, they were projects involving sweat, mathematics, logistics, and real materials. They required the cutting of forests, the mining of mountains, and the organization of thousands of workers. By understanding the physical reality of these structures, we gain a deeper appreciation for the history they shaped. They remind us that while stone and gold may crumble, the narratives built upon them endure forever.